Hello everyone, I'm here again with another one involving complex locus, and today we are going to solve this argument of z plus 2 over z is equal to pi over 4. So let's get started. So as usual, replace z with its rectangular form. Replace z with its rectangular form, x plus yj plus 2 over x plus yj is equal to pi over 4. Okay, and now let us separate the real and imaginary parts. Okay, so we have x plus 2 plus yj over x plus yj is equal to pi over 4. Okay, we've just separated the real and imaginary part, and that is what we now have. So inside here, since these are two complex numbers and they're being divided, we need to divide them the way we usually divide complex numbers. So what we now have will be x plus 2 plus yj over x minus x plus yj. So multiply the numerator and denominator with the complex conjugate of the denominator. Okay, we are multiplying the numerator and denominator with the complex conjugate of the denominator. So let's work out the numerator first. X minus yj plus 2 x minus yj plus yj x minus yj. Remember, this is the numerator, multiplying everything in the numerator with the complex conjugate of the denominator. So let's simplify to the x squared minus xyj plus 2x minus 2yj. Open that will be plus xyj. Here we'll get y squared j squared, but j squared is minus 1, so this will reduce to y squared. Okay, so this and this will cancel. Okay, we now remaining with x squared plus 2x minus 2yj plus y squared divided by, so that's the numerator. For the denominator, you need not worry yourself. All you need to do is square the real part plus square of the coefficient of the imaginary part, and that's it. So let's separate the real and the imaginary parts. So this will be x squared plus 2x plus y squared over x squared plus y squared minus 2yj over x squared plus y squared. Okay, we haven't changed anything, we have just separated the real and imaginary parts. Okay, same thing, we have just separated the real and imaginary part. So this is what we now have. argument of x squared plus 2x plus y squared over x squared plus y squared minus 2yj over x squared plus y squared. That's the complex number now. Okay, and it should be 4. So since this is argument, we're dealing with argument here, and to get the argument complex number, it is always the tan inverse of the imaginary part, the coefficient of the imaginary part. This is the coefficient of the imaginary part. Okay, and we need to divide that by, we divide it by this, the divide it by the real part. So I'm going to do that in one step, just by flipping the denominator to the numerator and multiplying. Okay, I hope you get that. I'm doing it in one step. I know you understand. Plus 2x plus y squared should be equal to pi over 4. So this and this will cancel out. Okay, so that we now remain tan inverse of this is what we now have. So we get rid of this tan inverse by introducing tan on the right hand side. Okay, so that we now have 2y over x squared plus 2x plus y squared is equal to tan of pi over 4. Okay, now tan of pi over 4 is 1, so this will be 1 over x squared plus 2x plus y squared is equal to 1. So cross multiply, you'll get 2y is equal to x squared plus 2x plus y squared. Okay, we want to take this 2y to the other side, so that we now have x squared plus, x squared plus 2x plus y squared plus 2y is equal to 0. And now let's complete the squares of this. Let's complete this square. It will be x plus half the coefficient of x squared minus 1 plus y, complete this square now, plus half the coefficient of y, half the coefficient of y is 1 squared minus 1, that should be equal to 0. Okay, so what we now have is x plus 1 squared plus y plus 1 squared minus 1 is 2, minus 2, so we take it to the other side, it will be 2. So this is the equation of our locus, and it proves that it is a circle. It is indeed a circle with center minus 1 minus 1 minus 1 minus 1, and the radius is root of 2. Okay, I hope you guys understand that. Thank you for staying with me. Please is understanding math.